Hi, so this question is evaluated divisions. So you give in the equations, which is the list of lists. Value, it should be a list, and queries should be a list of lists. So what you need to do is, so I'm going to summarize this, but what you need to return is return all the answer to all the queries. If there is a single answer cannot be found, just return -1. So how do you determine? It's going to be this. So A, hold on. So equation AIBI is going to be represent what? AI divided by BI is equal to value I, right? So this is going to be A divided by B, which is represent 2, B divided by C, which represent 3. So in this case, just do the math. So A equal to 2B and then B equal to 3C. So in terms of that, you can say A equal to what? 6C, right? So if this is the case, so what is A divided by C? You will return 6, right? So this is the answer, and then use this logic, and then we can traverse the result for the division. So one of the list question is, how do we map? We can only map the value in here, right? So the more data we have, the better result we get, right? But the queries equation should be the queries division should be the one we should care about. If there's a one, either the start or the end, so I'm going to call this start, I'm going to call this end, it's not found in the map, which is here, I'm going to return -1. So this is straightforward. So in this case, I'm going to use a hash map. So yeah, let's stop recording a little bit, and then in the meanwhile we'll explain. So I'm going to move my hash map to the top because I will reuse this. So what you need is the key is going to be the string. So string represent the node probably, or you can say vertices, right? And the value is going to be represent the edges that you to the other point, and then so this is going to be the edges, right? And this will be the value. So it's going to be, so in this case, so let me just start it. So if this is the case, I'm going to initialize a map, new hash map, and then I'm going to traverse the equation. I need to get an index, so I less than equations size I plus plus, and then string A equal to equations dot get I dot get 0, right? And then B equal to equation dot get I dot get 1, and then the double is definitely what values at value equal to values at I, right? So I'm going to initialize my hash map for A and B, right? I need to initialize the key. So map.compute if absent A, comma, and X to initialize this, right? So I will say A, so right here. So we know A divided by B is equal to 2. So this is A, and then we need to make sure the H. So this is the beginning, so which is H. One of the vertices, and this is going to be the other one, so it's going to be B and then comma 2, right? So if this is the case, what happened to B2A? So look at this. If I put a B right here, so I'm going to twist this, so it's going to be A divided by 2 equal to B, right? So if this is the case, I'm actually 1 divided by the value, right? So let me do this. So you can twist this to here. So A divided by B equal to 2, you can become A equal to 2B or B equal to what? A over 2, right? So this is how the math works. So if you don't know, then I don't know, this is how it is, right? So if this is the case, I'm going to just say b comma a and then 1 over the value, right? 1 over the value. So this will be the value I assign. So I'm going to say put the b comma value and then math.compute bx new hash map. Put a1 divided by the value. So it would be nice because we have double, right? If there's an in, then we have power. Alright, so once we initialize the map, yeah, we can start doing this. So what I need to return is a double array. Double array result equal to new double. So the size is going to be represent the length of queries, right? Queries size, and then return result. I'm going to traverse the queries, so I less than queries size I plus plus, and then I'm going to say string c equal to queries dot get at I dot get at 0. It will be similar to the above, and this will be exactly the same thing but for the get 1. And then now we need to figure out like which is the result, right? So I'm going to say result I equal to dfs c comma d comma hash set. So what is the hash set doing? I'm going to remember for list from C to D, I'm going to remember which node I'm using. If I use, I don't traverse again. So I reinitialize every single time. And it's, this is in dfs string star represents C, string D represent N, and then hash set. And then this is going to be represent string because I'm adding the node into the string. I'm going to say sin. You can say visit, doesn't matter. Alright, so if the map doesn't contain the star, right, or map doesn't contain the N, I'm going to return -1, right? But it's not just -1, it's -1.0. So if that's the case, this in is not allowed. Alright, so this will be it, right? So if the star is equal to the N, right, I'm going to return 1.0. So how can I beat like that? So starting and end will dynamic change based on my input. So I will have to have a variable. I'll have to have a variable to keep on track of the double, right? But not now. I'm gonna just add a star into the scene, and I will create a hash map string double. So it's going to be called neighbors. So this neighbor is going to be the map.get the star, right? So based on the star A, so if there's anything related to A, I will get this hash map, and this will be the neighbor of A, right? So I'll traverse. So this is pretty much like BFS in the DFS method. The string neighbors, right? Yes, spell this correct. Oh, spell neighbor wrong. N-E should be E. I don't know. Should be, yeah, it should be correct. Alright, if the scene doesn't contain the value, which is going to be neighbor, you can traverse. So this will actually keep on track. You are traversing the new node, right? So again, you need to get the value, right? You need to get the value, and then later on you want to return the value v, right? So yeah, v is what? V is something that you get 1 or -1, right? This is how it is, right? So dfx, and I'm going to say since you have neighbor, right? So your neighbor will change for the star, right? And then your n is not changing, and your sin is not changing, right? So if the v does not equal to -1.0, you can return right here, right? You can return the neighbors.get a neighbor times v. So what does this mean? This is something that we find in here. It's a value. It's a ratio. It's a ratio, right? So you don't care like what is this. you care what is the value, what's the ratio for the neighbor, and you times b, and then you recursively up to here. So this is how you get. So in this one, you will definitely get -1 and 1.0. But in this one, you are not going to get a 1 or -1, right? You are depending on your value, right? So this is pretty important. And once you finish, and then you want to just return what? First thing you want to return -1.0. If you cannot return right here, you want to return -1.0. And also you want to release the star for others node, right? So remove the star. So in this C to D traversal, it's easy, right? Oh, sorry. I mean, if there are any complex node right over here, you want to release the node you attempt to try for others, right? So imagine A to C, and C have multiple value, E, G, F, K, and E you have multiple value, G have multiple value, something like this, right? So this is going to be a max. So you want to release the star for others traversal use, and then this should be the whole solution. Hopefully I don't make a mistake. I do neighbors, copy paste. Come on. Let's spell this one. Oh wait. For each dot. Okay, 1 sec. Oh, I know why. I'm traversing the key, right? And then the neighbors get the star, right? Get a star. So I'm actually get this one, and the neighbor from A to someone else should be the key set. It's not just the string and double. It should be the key only. And then in here we will traverse the traverse the value for the V. This is the only problem, I believe. Okay, so this is hard. I'm going to say this is hard. And then the time and space for this one, okay, a little bit complex. So for this one, it's all of E, right? All of E represent the size of the equations. And alright, so times all of E. This one is all of Q, and then this will be what? DFX. So in this one, you will have all of the neighbor, which represent all of E, right? You can have one edges connect to all of the other edges, right? So Q times E, right? All of Q times E, and inside here you have the DFX. So I would say plus E right over here, since you are actually decreasing your node, right? So time would be all of Q times E plus E. Should be correct. And then space is going to be this guy and this guy. So it's going to be all of E for the edges, right? It's going to be here, queries, and then all of this one determine the node in the equations, right? So I'm going to say all of E for here, and then the total number of node inside the equations. So it might be, this might be it. So if you have a question, leave a comment, and I will see you next time. Bye.